All right, for today, as you guys notice, I have the questions here. I have the notes on part of my screen. Next to it, I have Excel. I will be using Excel, where I do encourage you guys to use technology for this. Excel is a great technology. We can do it manually, but to be honest, it's not going to be that fun to do it manually. So again, I encourage you guys to do Excel. You guys have access to Excel. So what I'm going to be doing is that I'm going to be doing two plots. So let's say I do an experiment. We're going to call it plot one. And I do a second experiment, which I'm going to call plot two. But on each of my plots, on each of my experiments, I'm trying out two different treatments. I'm going to call one of them treatment one, and the other one I'm going to call it treatment two. My treatment one are going to be this black marks, and my treatment two is going to be this white squares. Let me zoom in a little bit so you guys can see. So I'm going to be asking you guys to complete these tables here, right? So we're going to do completing of these tables. The first thing I see on my plot one, and it says mean of sample one. You guys notice, so sample one are the black ones, and I want to do the average or mean, however you guys want to call it, of those numbers. So let me do here on Excel. Let me do my numbers. We can read those dot plots. My numbers are going to be 8, 9, 10, 10, 11, and 12. Right? I'm just looking at plot one, sample one, and I have to find out the mean of that. We know how to do mean easily, right? We add them all. We can add all of our numbers, and then we divide it by how many numbers we have. But look, this is what I'm gonna do. I'm gonna go here on this screen here. So I'm gonna do equals because I have Excel actually does math. So every time I do equals, I'm gonna tell it to operate. So what I'm gonna do, let me open parentheses, and then I'm gonna add all of my numbers on the top. So I'm just gonna go 8 plus 9 plus 10 plus 10 plus 11 plus 12. And then I'm going to close my parentheses. So I just added all my numbers. And then I'm going to go divide by. So you guys do see this backslash. And then I'm going to divide this by 6 because there are 6 of them. I press entered, and then it gives me my result of 10. So I'm going to say the average of sample 1 in plot 1 is 10. So let me answer that over here. 10. Okay. Now I can easily do here in plot one, the average of sample two. You guys see the sample two here? Let me get my numbers here. So matter of fact, let me leave some space here. I'm not gonna do my list right next to it. I'm gonna use this space later on. So again, I'm gonna go here to the side. It doesn't matter how much to the side, at least leave like 3 or 4 spaces. So at least 3 or 4. Okay. So my numbers are gonna be, let's see, 13, 14, 15, 15, 16, and 17. I'm going to come down here. Then I'm going to do the average of that. So remember, I'm going to press equal. I open parentheses, and I'm going to add them all. So 13 plus 14 plus 15 plus 15 plus 16 plus 17. I close my parentheses. To finish adding, I divide this by 6 because there's 6 of them. And it tells me my average, the mean of sample 2 is 15. Okay. So I'm going to write 15. Now here on plot 2. So my focus is going to be here on plot 2. I have to do the sample, the mean of sample 1. So I'm going to come down here, and I'm going to say, all right, I can see the numbers of sample 1 in plot 2 are 6, 6, 8, 11, 14, and 14. I'm going to do my average. So I'm going to do equals, open parentheses, 6 plus 6 plus 8 plus 11 plus 14 plus 14, close parentheses, divided by 6 because there's 6 of them. And it tells me, gives me a long decimal number. Good thing here it says round to 3 decimal places as needed. Okay, so if I do have long decimals, round it to 3 decimal places. So I'm gonna go 9, oops, 9.833. Okay. Now for my answer here, I will round it to 3 decimal places. I'm gonna use this number later. I'm gonna use this number later, and on my answer later, I'm not rounding anything. So for later, I have to use the whole decimal number. Okay, but for right now, let's just leave it at that. Okay, my mean of sample 2 from my plot 2. So notice plot 2, my sample 2. Let me look at my numbers. It is, let's see, 12, 15, 15, 16, 17, and 17. Gotta do the average of that. So I'm just gonna open parentheses. Remember, equals, open parentheses, 12 plus 15 plus 15 plus 16 plus 17 plus 17, close parentheses. Don't forget to close the parentheses here and then divide. There's 6 of them, so I'm gonna divide by 6, and it tells me this big decimal number, which I'm gonna round this to 15.333. Okay. Now this is where it's actually gonna start getting fun. Okay. Use the means to calculate the sum of the squares for treatment. So the sum of the squares, we're gonna repeat it at SST for each dot plot. Okay, so looking at my plot 1. So remember, my plot 1 are these numbers on the top. Looking at plot 1, I would like to know what's the average. So what's the average of all the numbers in there, whether they're sample 1 or sample 2. So I want to know what's the average of plot 1. Okay, so let me do it here. I want to put some space there. So I'm going to go equals. I'm going to go parentheses. So I have to go 8 plus 9 plus 10 plus 10 plus 11 plus 12 plus 13 plus 14 plus 15 plus 15 plus 16 plus 17. Close my parentheses. So I added all my numbers in plot 1, whether they were sample 1 or sample 2, and I'm going to divide this by 12 because there's 12 numbers. So I'm going to say my average of all of them is 12.5. Okay. Now this is what I'm going to be doing. Um, I'm going to say, because on my list here, there's 6 numbers. So this is the formula I'm going to use right now. Because on my first plot, on my sample 1, there's 6 variables. So I'm going to do 6 times. So I'm going to open parentheses. And then here I'm going to say the average of plot of sample 1, which was 10, minus the average of the whole plot. So again, here my average of the whole plot is 12.5. Close parentheses and square. So again, I look at my first plot because I'm just looking at plot 1, and I see treatment 1. There's 6 numbers, so there's where my 6 comes from. And I do in parentheses, I subtract the average of sample 1 minus the average of the whole plot, all squared. Now plus, I'm going to be looking at still plot 1. I'm going to be looking at sample 2. There's 6 numbers, right? There's 6 numbers, so I'm going to put 6, open parentheses. I'm going to do the average of sample 2 minus the average of the whole plot. So I'm looking at 15 minus 12.5 square. So I just wrote what I need to type. Okay, now let me worry about the typing. I'm gonna say okay. And as a matter of fact, let me write the information down. We're gonna call this SST. Okay, we're gonna call that SST, which is the sum of squares for treatments. I'm gonna go equals. So once again, I'm gonna calculate something. I'm gonna go 6 times. For times in Excel, you see that little start? That's what we use. I'm gonna open parentheses, and then I'm gonna go 10 minus 12.5, close parentheses. Well, as a matter of fact, better yet, I'm not gonna write 10 minus 12.5. I'm gonna click on the cells. Here's this one's 10. I'm gonna press minus 12.5, close parentheses. Actually, I could have easily just typed 10 minus 12.5. However, what if one of my numbers, and obviously we're going to see that in plot two, what if my numbers was a never-ending decimal? So I don't want to round to anything, so I'm going to have Excel do everything here. So then I'm going to go to the second. So I'm going to go shift, and there's by the 6, there's a little thing that looks like an arrow going up, which we call caret, and then I press 2, and then plus, I go 6 times, open parentheses, and I'm going to have 15 minus 12.5, close parentheses, and to the second power. Again, here when I wrote this, I wrote the numbers that I needed. When I do it here in Excel, I don't write the number. I actually use what we call this, the little cell here. We call those cells, each of these little rectangles. Okay, so I press enter, and that's going to be my sum of squares for treatments on plot 1. So that's 75. Okay, so let me just call this 75. Cool. It's not an ugly number. Now let me take a look at plot 2. Remember, I called my SST here. Now my SST for plot 2. Let me write this first. Let me write what I'm going to write. Well, I have to do my average over here still, right? I haven't done my whole average of plot 2. So I'm going to go equals, open parentheses, 6 plus 6 plus 8 plus 11 plus 14 plus 14 plus 12 plus 15 plus 15 plus 16 plus 17 plus 17. And then I'm going to divide this by 12. So my whole average for the whole plot is here. Okay. So let me write this. I'm going to write what I'm going to type. So I'm going to write it first. I see on my first sample, on treatment sample 1, there's 6 numbers. So I'm going to write 6, open parentheses, the average of that sample minus the average of the whole plot. So I'm going to write it by hand right here. I'm going to write 9.83 and then a bunch of threes. I'm going to put this little line on top minus 12.58 and a bunch of threes. Like I said, I'm not going to round on my work. Plus, the good thing that Excel's actually going to do the whole work for us. Now I see on plot 2, sample 2, there are 6 numbers. So I'm going to put a 6. And then the average of those numbers is 15 point and a bunch of threes minus this number 12.58 and a bunch of threes. Okay, so I'm gonna do it up here. Press equal, and I go 6 times open parentheses. The 9.83, I got it from here. So see how I click on the cell minus this cell, close parentheses. Oh, I forgot this. Each of my parentheses goes to the second powered as well. Kind of like how we did on the first one. See how my parentheses went to the second powered? I'll come and fix that in a minute. But notice how I typed it to the second powered plus 6 times open parentheses. And I'm going to have this 15.3333 minus this one, 12.583, close parentheses, and do it to the second power. Press enter. So let me fix this. This parentheses and this parentheses go to the second power. Okay, so my SST, so the sum of the squares for treatment on plot 2 is going to be 90.75. Okay, so not that bad. 90.75. Okay, so far so good. Okay, so I have the sum of the squares of treatment for plot 1 and for plot 2. I'm going to come back to these numbers later. So that's why I left it there. Okay. Now we're going to do, let's see here, it says calculate the sample variance for each sample and use these values to obtain the sum of the squares of for error, which we're going to abbreviate as SSE for each dot plot. Calculate the sample variances. Okay, so the sample variances, this is what we're going to do. And that's why I need you guys to do this in Excel. We're going to use technology for this. What I'm going to be doing is I'm going to press equals. See the next to this 8. Notice how I'm looking at plot 1, sample 1. And I'm going to go this number, so the 8 minus the average. Okay. So notice I'm going 8 minus the average. For the next number, I'm going to do this number minus the average. So I'm basically going to do the subtraction of each of these numbers minus the average. Sometimes my difference might be 0, might be a positive, might be a negative. It's just the difference between those two. And I literally type the difference on each of those. There's ways on how to just click on it and then drag, and the Excel does everything for you. But I just did that, so I'm just gonna do the difference here. But then here in the next scale, I'm gonna go equals. I want this number squared. So each of my differences, I'm gonna do square. So here I'm gonna go this number squared. Let me do this. Just notice I'm squaring each of my differences. And then I'm going to add them all up. So for my variance, let me just come here at the side. Let me call this sample variance. I'm going to call SSE. I'm going to use these numbers later. So it it is useful if I label them. So I'm going to use SSE for the sum of the squares for error, which is basically the variances of each of these. Okay. I'll come back to this variance in a minute. What I'm going to be doing is, again, for each of my tables, I'm going to go the numbered minus the average. There we go. I'm gonna go the number. Oops, no, click wrong. Is this numbered minus the average? Remember, every time you're gonna ask Excel to do some math operations, you have to start with an equal sign. And then this number to the second powered. As a matter of fact, in this case, I can just drag this and it did each of those to the second powered. And now here, let me go this one minus this. So I'm gonna do it in all of these. Again, there's symbols. I don't want to talk much about how to type this, but it can be typed a little bit faster. So I'm going slow motion. So is this number minus the average? And I'm gonna do this number to the second powered. So it looks something like this. And then here, I'm gonna go this number minus the average. Let me take these things up here. Then I have to go 15 minus the average. 16 minus the average equals 17 minus the average, and then equals 17 minus the average. And then from here, I'm going to say this number to the second power. Cool thing is that I can add them all. So, okay. Now for my variances, let me come back to plot one, sample one. I'm going to be looking at these squares. Remember, I did the average and then I do the squares. What I'm going to do, I'm going to add them all first. So I'm going to press equal. I'm going to add all of these. And I can press 4 plus 1 plus 0 plus 0 plus 1 plus 4. This case is not that bad, but it's going to be ugly on plot 2. So instead, what I'm going to be telling Excel to add them better, I'm going to say sum. Notice I did sum because I'm going to do a sum. So I'm going to add. I open parentheses and I highlight the numbers that I wanted to add. Close parentheses. If I press entered, it's going to tell me how much they added to. But I'm not looking at how much they add up to. I'm looking for the variance. So I'm going to divide this. So notice how I added everything. So I added these numbers and I'm going to divide this. Now, interesting here though, because it is the sample variance, I see how many numbers I have and I'm going to divide it by one less number. So there were 6 numbers that I added. So I'm going to divide this by 5. Again, because it's a sample variance, I divided by one less. Okay, so I press entered, and my sample variance of sample 1 is 2. Okay. Now let me do sample variance on this next one. I'm going to go equals sum, because I'm going to add them. I'm going to open parentheses, and then I highlight all of the numbers that I want to be added, close parentheses, and I'm going to divide by 5. Again, there's 6 numbers, but for sample variance, I divide by one less. Okay, so this one's also 2. Now this is what's going to be interesting on plot 2. I'm going to do equals sum, open parentheses. I'm going to tell it to add all of these numbers. Notice I'm not rounding. I'm not rounding at all. I'll just say add all the numbers divided by 5 because there's 6 numbers and I divide by one less. So on plot 2, My variance of sample one is 13 point. Okay, and it gives me a long decimal. But now here, for this answer, so for my answer on this table, it says round to 3 decimal places as needed. Okay, now this one I do have to round it. So I'm going to call this 13.767. Okay, so here I am going to round it to 13.767. You guys see where I got the number from. Now for here, for variance plot 2, sample 2, I'm going to do equals sum, open parentheses. I add all of these numbers and then divide it by 5. And then my variance in this case is going to be 3.467. You guys see that? Okay, let me come here. I'm going to need these answers later. So let me save them so I don't forget them. So equals this numbered equals this numbered equals this numbered and equals this number. Okay. So you see we have them on our table here, but I saved them over here because like I said, I'm gonna need them later. But here I'm not gonna need them rounded. I just need the whole thing. Okay. Let me clear this handwriting that I have here. Okay, now we're gonna calculate the sums of the squares. So SSE, we're gonna calculate the sum of squares for error. So notice how for plot one, I only have one space on my table. Well, for plot one, I'm gonna add my SSE from plot one. Now here, this is how we're gonna do this, okay? I'm looking at plot one. But plot one, we have 2 errors, right? You guys see 2 and 2. I have the error for sample 1, have the error for sample 2. Let me write down what we're going to be doing, okay? So first of all, I see how many numbers were there in plot 1, sample 1? 6 numbers. For this one, I'm going to do one less. So let me go 5 times my variance of sample 1, which is 2 square. See that? Plus, I'm going to see my sample 2. How many numbers are there? 6 minus 1, because I'm going to do one less. So 5. And then my variance was 2, right? Square. And that's going to give me my sum of the squares for error from plot 1. Now, what I'm going to do for plot 2, let me come here real quick. There's 6 numbers, right? So one less, it's 5. Now, what was the variance here? This number, right? So I'm going to call this right now I'm just going to call this 13.7 and a bunch of sixes squared plus looking at sample 2. There's 6 numbers. So I'm going to say 5 because I have to go one less. And what was my variance on that one? It was 3.4 and a bunch of sixes. Okay. 3.4 bunch of sixes all squared. So I just wrote down what I'm going to be typing. So let me keep my labels here. Okay, my labels here, I'm going to do the sum of the squares. As a matter of fact, let me go here. Equals 5 times open parentheses, and I click this to the second power plus 5 times open parentheses, and I click this to the second power. Oh, it there. It was marking that wrong 5 there. Hold on, this is doing it wrong. Let's see. Let me do this again. It was 5 times this to the second power plus 5 times this number to the second power. Oh, no, I have to do it to the variance, right? Hold on. Where's my eraser? It's not to the second power here because my variance is already to the second power. I actually have to go equals 5 times my variance plus 5 times this other variance. Okay. Remember, there were 6 numbers, so 6 minus 1 is 5. My variance was 2. So 5 times the variance plus my older list, there were 6 numbers, so 1 less. That's where I get the 5. The variance is 2. So I have to go 5 times 2 plus 5 times 2. So it's going to give me 20. Okay, 20. Now you don't have to type in decimals. I know here it says round to 3 decimal places as needed, right? 20 doesn't have decimals, so just leave it at that. However, here on plot 2, this is going to be interesting. So let me type this number. So I'm going to go equals 5 times this number plus 5 times this number. I have them there, so might as well just use them. So here I'm going to have, here I have rounded to 3 decimal places, right? So was that 86.167? 86.167. Okay. As a matter of fact, let me call that my SSE. So let me not do here. Let me call this my SSE. My SSE word 20 for the first plot. And let me copy this number. 86.1 and bunch of sixes for plot 2. That's going to be my SSE. We'll use that later. Like I said, I want to save those there for a minute. Now, my total here. Calculate the total sum of squares, which we're going to call SS total. The total sum of squares for the dot plot by adding the sums of the squares for treatment and error. What percentage of SS total is accumulated by the treatment? That is, what percentage of the total sum of squares is the sum of the squares for treatment in each case? Okay, so for my SS total, what I have to do, let me write down here. Let me write it here. I'm gonna say my SS total. So I'm gonna do a T here. Is gonna be equal to my SST plus my SSE. Now you guys see why I was labeling my numbers earlier. My total sum of the squares is going to be equal to my sum of squares for error plus my sum of squares for treatments. Okay, so from plot one, what do we have from plot one? My SST from plot one is 75. My SSE from plot one is 20. So I don't think I need to do much, right? 75 plus 20, we can use a calculator. We need to. I'm just going to call that 95. My SS total for plot one is 95. What about my SS total for plot two? Okay, so here I have to add 90.75 plus 86.166666666. Okay, now this one I'm going to calculator here at the side. So matter of fact, let me just write that here. SS total. One of them for plot one was 75 plus 20. And for plot two, it's going to be 90.75 plus 86.66666. And my answer, I have to round it to 3 decimal places. So I'm going to call this 176.917. So 176.917. Now here it says SST percentage of SS total. Okay, so I know for a percentage, I have to go SST divided by SS total. So for my plot one, let me press equal. What was the SST of plot one? 75. Let me divide this by the SS total. So 75 divided by 95. Now we learned that that's going to give me a decimal. And for percentage, I want to see this as a percentage. So I'm going to let me multiply this by 100. So it's going to give me 78.947. So 78.947. Now for plot two, when I press equal, what was the SST on plot two? 90.75 divided by SS total. So 176.9167. Okay. And let me multiply this by 100. So I'm going to say my percentage here is going to be 51.295. So 51.295. Okay. Now I promise the rest is going to be pretty simple. Let me erase this formula that I wrote by hand here. Okay. So let me call this SST percentage. Now we're going to convert the sum of the squares for treatment and error to mean squares by dividing each by the appropriate numbered degrees of freedom. Okay, there's going to be a couple degrees of freedom. Now, let me see. Let me write this. I'm going to use N and I'm going to use K. These are my two variables I'm going to be using, N and K. Now, N is how many samples are there in a whole plot. So if I was to look at plot one, how many samples, how many squares are there in plot one? Obviously, if I'm looking at plot two, is how many samples, how many numbers were there in plot two? That's combining samples one and samples two. Now, to be honest, on each of my plots, there were 12 samples in this case. Now, K is going to be how many treatments were there on each plot? How many treatments? To be honest, in this case, it's going to be 2 treatments on each plot. So when I say N, is how many samples were there altogether in the plot? K is how many treatments were there in the plot. Okay, so I'm going to use N and K as my numbers. For my MST, I'm going to go my SST divided by K minus 1. Because of my degrees of freedom, I had to subtract 1. So my SST divided by K minus 1. That's going to give me my MST. Now my MSE, so for my error here, remember this is the sum of the squares for treatment and then the sum of the squares for error. Okay, so we're going to convert this to mean squares of treatment, mean squares of error. So now for this one, the formula I'm going to use is SSE divided by N minus K. So there, I wrote down what I needed to write. So for my MST on plot 1, let me just label here my MST and my MSE. So for plot 1, I'm going to go equals. The SST is 75 divided by 1. Because remember my formula is K minus 1, but my K is 2, so 2 minus 1. So that's going to give me 75 for my MST on plot 1. Now let me do my MST for plot 2, since I have it here. So I'm going to go, okay. What was the SST on plot 2? 90.75. And then divided by K minus 1. But K is 2, so divide this by 1. And it's going to give me, in this case, 90 point 90.75. I know it says round to 3 decimal places as needed. I stop at 2, right? You don't have to type in 3 decimal places. Now for my MSE, okay. For plot 1, so let me go equals, what was the SSE? It's right here, 20 divided by N minus K. So that's 10, right? N is 12, K is 2, so 12 minus 2 is 10. So my MSE for plot 1 is going to be 2. For plot 2, let me go SSE. Oh no, plot 2, right? Divided by, in this case, by 10 as well. Now here for my answer, I do have to round it to 3 decimal numbers. So I'm going to call this 8.617. And then to finalize this question, I'm asking for the F ratio. Okay. Now calculate the F ratio of the mean square treatment, MST, to the mean square for error for each dot plot. Let me clear these drawings here. Now ratio. How am I going to do my ratio? Now my ratio, let me write the formula that I'm about to use. So here, let me write it in my hand, by hand. My MST divided by MSE. So for rate for plot one, let me go equals. Remember the MST for plot one was 75? Let me divide this by the MSE, which is 2. So my ratio is going to be 37.5. Now plot 2. Let me go here. I'm going to go equals. Remember how my MST was 90.75? Divided by MSE, which is this number. Now this answer, I'm going to round it to 3 decimal places. So I'm going to call that 10.532. Okay, use Excel as a calculator. I don't need Excel for the next few questions. Let's see here is use the F ratio of plot 1. So notice my F ratio is 37.5 to test the null hypothesis that the two samples in plot 1 are drawn from the populations with equal means. And then take our alpha to be 0.05. Okay, now here I gave you guys a website. I want you guys to do this, use this website, okay? Now I have to come up with a null hypothesis and alternate hypothesis. So let me draw here my null hypothesis and my alternate hypothesis. Okay, so here it says use the F ratio for plot 1 to test the null hypothesis that the two samples in plot 1 are drawn from populations with equal means. Okay, so the null hypothesis is that the mean of 1 is equal to the mean of 2. That's going to be my null hypothesis. Now, my alternate hypothesis, I can write that the mean of 1 is not equal to the mean of 2. Or in words, but I don't want to write the mean of 1 is not equal to the mean of 2. I could have said that two treatment means are different. Right? That's basically what it is in English. I just wrote it in symbols. The mean of 1 is not equal to the mean of 2, but I could have said that two treatment means are different, right? Okay. So I found that. Now I have to find my F ratio to plot here. So let me find my p-value. I'm going to find my p-value. I'm going to use this website. Let me open this website really quick. Okay, here's my calculator. The p-value from F ratio calculator. Now my F ratio for plot 1 was 37.5. 37.5. But then I have degrees of freedom of the numerator and degrees of freedom for the denominator. Okay, let me tell you guys how we're going to figure out the degrees of freedom. For the numerator, it's going to be k minus 1. For the denominator, it's going to be n minus k. And remember, for plot 1, our k is how many treatments. So in this case, we had 2. And n is how many values were there all together in plot 1, whether they were treatment 1 or treatment 2. In this case, 12. Okay, so my numerator, degrees of freedom, is k minus 1. I know k is 2. So 2 minus 1, I'm going to say 1. For my denominator is n minus k. So 12 minus 2, I'm going to call this 10. And in here, significance level. I was told to use alpha to be 0.05. So use 0.05. I'm going to scroll down. I'm going to press calculate. And then here, it gives me my p-value. Okay. But I here I have round to 3 decimal places. So round it to 3 decimal places. In my case, I'm going to say 0.000. You guys see it? 0.000. Run it to 3 decimal places. Now use the F ratio for plot 2. Oh, we had to determine, right? Now here, my p-value is 0. My alpha is 0.05. Because my alpha is bigger than my p-value, I'm going to say reject the null hypothesis. Reject the null hypothesis. And why am I saying this? Because alpha is bigger than p. If p would have been bigger, then I would accept the null hypothesis. So there is sufficient evidence to show that the samples are drawn from populations with different means. Okay, now let's take a look at plot 2. I'm gonna say, okay, here I have to come up with a null hypothesis as well, and an alternate hypothesis. And I'm gonna say, use the F ratio for plot 2. So I'm using plot 2. I'm using the F ratio from plot 2 to test the null hypothesis that the two samples in plot 2 are drawn from populations with equal means. Okay. So the mean of 1 is equal to the mean of 2. That's what the null hypothesis. So I'm going to say my alternate hypothesis is they are not equal. I can say this in symbols, or in words. I would have said that the two treatment means are different. Okay. Now let me use my calculator here. My F ratio in this case is going to be 10.532. My numerator is still, the degrees of freedom, my numerator is still going to be 1. My degrees of freedom of the denominator is going to be 2. My significance level, I'm using alpha to be 0.05. Okay, let me calculate this. Round it to 3 decimal places. So in this case, let me do here. I'm going to say it is going to be 0.009. Okay, so I have to check here. Remember, all I'm checking is I want to compare my alpha and my p. Alpha is 0.05. My p is 0.009. Which one is bigger? Alpha. Okay, because alpha is bigger, let me reject the null hypothesis. I am rejecting it. I'm rejecting it because I have sufficient evidence to show that the samples are drawn from populations with different means. Now, this calculator for your p-value, it is included in your notes. You guys see it. You guys see your calculator, so there.